Good morning, everybody. Thank you for joining this webinar. Topic of this webinar is a new network for the multi-cloud era. The new network for the multi-cloud era is enabled by the VMware Virtual Cloud Network. Quick introduction from my side before we get started. My name is Joshua Cooling. I'm a networking and security specialist systems engineer based at VMware. So I'm responsible for the full VMware networking and security portfolio, which is formed by the Virtual Cloud Network. I'm going to spend a few minutes before we get started talking through what's driving the need for a new networking model in a multi-cloud enterprise, and why do we see these demands being placed on enterprise IT. I'll spend a few minutes looking at the journey that VMware have been on with regards to networking and security, so through product development as well as organizational acquisition. How do we find ourselves where we are today, as well as taking a look at some of the components of the virtual cloud network itself. We'll then look at some of the use cases that we can enable using technologies like NSX in a multi-cloud enterprise IT environment. So with that, let me make a start. So ultimately what we see is that every enterprise IT organization is on a journey. That journey is evolving how they run and distribute their enterprise applications. So every customer that I talk to is somewhere along the journey of looking at how they can distribute and run applications and services within the public cloud. And many of the organizations that I'm working with, depending upon the industry vertical that they're within, are also looking at how they can distribute applications and services out to an edge location. Clearly, there are use cases whereby it makes sense to have applications and services distributed at these edge locations for aggregation and computation of data in an edge location before sending that data back to a centralized component of an application or a service. So every customer I'm talking to is somewhere along this journey. Every organization I'm talking to is looking at the cloud in some way, shape, or form. So what we see is an enterprise IT environment where applications and the data within those applications is distributed across a data center, a cloud, and an edge location. And this distribution of applications and data is driving a need for consistent control and consistent security and consistent networking across these three domains. From a VMware perspective, we enable this end-to-end consistency across these different domains using the virtual cloud network. At the core of the virtual cloud network are technologies such as NSX, but what we're now able to do is to provide this end-to-end fabric across, as you can see here, data center locations, across cloud locations, both VMware-based cloud destinations, such as VMware Cloud on AWS, or native cloud destinations, such as native AWS and native Azure. What we can also do is distribute this virtual cloud network into branch locations, into telco environments, and we can interconnect all of these different infrastructures together using our VMware SD-WAN by VeloCloud technology as well. So what we're able to achieve with the virtual cloud network is a platform that gives us this software-defined end-to-end fabric. Not only is this end-to-end fabric software-defined, but the entire architecture of the virtual cloud network can be delivered in software, but we give you the choice to deploy certain components in hardware should you choose to deploy on a hardware-based appliance. And the fact that this is all enabled in software is really important for us because it enables us to highly automate this software-defined fabric. It's very easy to scale out elastically a software-based architecture. And then the third key principle or property of the virtual cloud network is that we are making security intrinsic to the infrastructure. So we are enabling security capabilities that are an intrinsic part of the infrastructure. So across the hypervisor, as an example, we are embedding security controls. In the native public cloud, we're also embedding security controls. And the principle here is that rather than bolting on security controls to an architecture or to an infrastructure, we're actually making security controls an incumbent component of the infrastructures and architectures that we're building. So not bolted on, but a very much an intrinsic part of what it is that you build. As I said at the start, I just wanted to spend a moment and talk about the journey that VMware have been on with regards to networking and security. If we look at the bottom left-hand corner of this slide, we can see that VMware started their networking journey with the vSphere distributed switch. This is going back well over a decade now, but this really was our first implementation of a software-defined network. We had centralized control of the distributed switch, but the distributed switch is, as it says, distributed across every hypervisor. So this really was our first step into software-defined networking. We then embedded this within the other VMware or broader VMware portfolio as part of the VMware software-defined data center, which brought together network virtualization as well as compute virtualization and storage virtualization. We acquired a series of organizations, one of which we can see listed here, which was Nicira. This really accelerated our software-defined network virtualization capability. And over time, we developed the Nicira technology and embedded it with what we were doing at VMware, and through that process was born NSX. We led with microsegmentation as the lead use case for NSX initially. Further along this journey, you can see subsequent acquisitions we made. So we acquired an organization called Arkin, which gave us insights into NSX, and we badged this Network Insights. We developed out-of-the-box integrations with vRealize automation. This allows us to drive huge amounts of value from the network to reduce time to deploy, reduce time to provision applications and services. We enhanced NSX and announced something called NSX-T, which is our multi-hypervisor, multi-cloud variant of NSX. So clearly, the focus of the session today is multi-cloud era. NSX-T is a key enabler for us to execute against multiple hypervisors and multiple clouds. We developed something internally which reinvented the traditional endpoint security or application security approach. We marketed that as App Defense. So App Defense extends our least privileged network model that was enabled by NSX to the application domain. So we can now achieve what we call least privileged compute. We developed integrations with cloud-native application frameworks. We acquired VeloCloud and developed NSX Hybrid Connect, which provided us with connectivity and hybridity between these different cloud destinations. We developed public cloud integration, so we now support AWS, Azure for native public clouds, as well as a series of VMware-based cloud destinations such as VMware Cloud and AWS or the IBM Cloud. Most recently, we acquired Avi Networks. Avi Networks, we're now incorporating within the NSX portfolio as the NSX Advanced Load Balancer, and this really gave us a consistent way to enable application delivery across different private cloud, public cloud, and edge infrastructures. So all of these things encompassed in the virtual cloud network, which is where we find ourselves today. So all of this capability is encompassed by the virtual cloud network. The virtual cloud network we can see here across the bottom is underpinned by a set of networking and security virtualization technologies. In the bottom left-hand corner, we can see NSX Data Center. If you've come across NSX in the past, this is the variant of NSX that you will be familiar with. We then have now NSX Cloud, which extends NSX into native cloud environments such as AWS and Azure to provide us networking and security consistency between the data center and the cloud. We now have the NSX Advanced Load Balancing, or Load Balancer solution. This provides us with full layer 7 capability load balancing, as well as WAF and also deep application telemetry and analytics. We have App Defense, which extends the least privileged security model from the network that was achieved with NSX to the applications themselves. We can now extend this software-defined layer across the wide area network using VeloCloud, and we can provide hybridity between disparate vSphere environments using NSX Hybrid Connect. So all of these technologies are the virtualization technologies that enable the virtual cloud network. And as you can see, NSX is at the core of what we're doing with the virtual cloud network. Layered across the top of these virtualization technologies, we then have monitoring, management, and automation. That's enabled by two solutions. On the left-hand side, we have Network Insight. This gives us discovery and operational insights. And on the right-hand side, we've got vRealize Automation. This enables end-to-end automation of the full stack from compute through networking and through security. So I'm going to be focusing on NSX Data Center and NSX Cloud really as part of this session. And what we're doing with NSX Data Center, within the data center, we would always expect to see some physical infrastructures. And those physical infrastructures don't go away when you look to deploy technology such as NSX. So we will still always have physical compute, physical networking. NSX really has two dependencies on the physical infrastructure. One is that it provides IP reachability, and the second is, given we create an overlay, we need a slightly larger MTU for the facilitation of NSX. However, you can have any form factor compute, whether it's rack mount, some form of converged compute or hyper-converged compute. And from a physical network fabric perspective, it can be any physical network fabric from any vendor deployed in any topology, whether it's a traditional three-tier data center network architecture or a consolidated cloth leaf spine data center network fabric. But ultimately, we are completely agnostic to what is used from a physical network infrastructure perspective. But layered across the top of these physical infrastructures, we then have the NSX platform, on top of which we would then sit the hypervisor. And what we're doing with NSX Data Center across the hypervisor is taking core networking and security services such as firewalling, load balancing, routing, and we're embedding those services into the hypervisor. Not only do we support traditional virtual machine-based workloads, but we now also have full support for containers, where we've developed integration with technology such as Kubernetes. What we're able to do with all of these different types of workloads is attach them to networks in NSX. We can route between those networks in NSX, and we can also wrap security policy around all of these workload types using the NSX distributed firewall. NSX itself is a platform that provides faithful reproduction of a broad portfolio of networking and security services. We enable switching. We create an overlay within which we're creating these NSX networks. We can route between these NSX networks within NSX. We can provide layer 4 through layer 7 load balancing. We provide connectivity to the physical network. That enables us to have end-to-end reachability between workloads residing in NSX and workloads outside of the NSX domain. Across the bottom, you can see some additional services that we provide, so layer 4 through layer 7 firewalling, including things such as URL or FQDN whitelisting. We have layer 2 and layer 3 VPN capability. Not only do we provide our own native services, but we also have an ecosystem of partners that can integrate with the NSX platform to augment the native capabilities within NSX. So we can integrate with industry security vendors such as Palo Alto or Checkpoint. Additionally, across all of these services, we provide deep visibility and monitoring of everything that's configured within NSX, and we have out-of-the-box integrations with monitoring tools from industry leaders as well as providing our own monitoring capability with Network Insight. Everything that I've just spoken about on the left-hand side, you can see is exposed through both a user interface, a web user interface, as well as an API. So everything I've just discussed can be programmatically configured using the API. The API has out-of-the-box integrations with vRealize automation, but ultimately it provides a fully RESTful API endpoint such that it can be automated using any tool that supports a REST API. Sitting below that, we have this concept of policy, groups, and tagging. So everything that I've just discussed can be configured to work with policies and groups. So as an example, I may want to group workloads together to then secure them using a security policy. And the groups may be defined using some form of tag, and that tag captures certain metadata that groups those workloads together. So NSX is a platform that enables all of these services. From a use case perspective, NSX really has 4 primary use cases, and I'm going to talk through these at a high level and then step through a couple of these in a little bit more detail. So starting from left and working right, the first primary use case of NSX is focused around network security. So the network security model of the past has been to very much focus on securing the data center perimeter. So at the perimeter of my data center, I'm going to put a large, highly capable, high bandwidth perimeter firewall. And that perimeter firewall is going to provide my inspection of traffic. However, what we see is that the vast majority of attacks follow a very similar kill chain in which attackers don't look to compromise data center perimeter security. Attackers will look beyond the perimeter to an asset within the data center that they can compromise. And once they've compromised that asset, because organizations historically have focused on securing the perimeter, they have relatively free movement within a data center. So over a period of time, an attacker will move laterally through the data center, identifying sensitive assets, identifying data, and over time exfiltrate that data. And what we see is that actually the vast majority of data center traffic is actually east-west, with the majority of that traffic remaining in the data center. The minority of traffic is traversing that north-south boundary and is actually leaving the data center. So this traditional approach to network security of protecting the perimeter actually doesn't provide a huge amount of value or visibility into the vast majority of data center traffic. So what we drive with NSX is a concept of microsegmentation, whereby we have a distributed firewall that runs in the hypervisor and actually runs in front of the individual virtualized workload itself. So each individual virtual machine now has a firewall running in front of it, such that any traffic that enters or leaves that virtual machine will go through the NSX distributed firewall. What you will also see is that we've now developed deep integration with bare metal workloads, such that we can now apply that same security model to a bare metal workload as well. What this means is that if somebody does compromise a system or an asset within the data center, we're able to very granularly segment the data center such that they will not be able to move laterally through the data center and exfiltrate that data over a period of time. And that's what we refer to as microsegmentation. The second primary use case of NSX, and this is a very recent use case and has been a huge area of investment for VMware, has been around cloud-native application architectures. So what we now have the ability to do with NSX is to integrate with these cloud-native application architectures and frameworks such as Kubernetes, and we've built an industry standardized integration with Kubernetes. So we support many different distributions of Kubernetes, including things such as Red Hat OpenShift, the Pivotal Container Service, or even just upstream Kubernetes. So we can now provide a full networking and security stack of enterprise-grade services to cloud-native workloads. So we can connect a container to a network in NSX. It may be the same network that a virtual machine is connecting to. We are treating containers as a first-class citizen with regards to networking and security. What we're able to do is to then secure those cloud-native application architectures as well, to give you end-to-end consistency between traditional applications and more cloud-native application architectures. And really what we've strived to do with this integration is not to inhibit the developer workflow. So everything that's available within the NSX platform for a cloud-native workload is highly automated. So we're not inhibiting the developer to do what it is they need to do. The third primary use case is automation. And I've already spoken to this a little bit, but everything that's available within the NSX platform is exposed through both a user interface as well as an API. And we can automate heavily all of the services available within the NSX platform using either an out-of-the-box integration with a cloud management platform, such as vRealize Automation, or you can drive automation directly into the NSX API to access and automate the provisioning of networking and security services in NSX to drive more of an infrastructure as code consumption methodology. So that was the third use case, primary use case of NSX Data Center. And the fourth use case is where I'm going to be focusing a little bit today, and that's with regards to multi-cloud networking. So multi-cloud networking is taking the services that I've spoken about already within NSX and doing one of two things with them: extending those services between data center locations. So I now have consistent networking between two data centers, such that now gives me workload portability or disaster recovery across data center locations. Or the other thing that this enables is for me to extend the NSX fabric into a public cloud location. Those public cloud locations could be formed of either a vSphere-based platform, such as VMware Cloud and AWS, or it could be a native public cloud destination, such as a native AWS, native Azure. And really what we're driving with that extension of NSX into those domains is consistency. So enterprise IT have consistent ways to deploy networks, consistent ways to secure those networks across both data center and cloud locations, such that adopting those new types of infrastructures doesn't become operationally burdensome. So those are the four primary use cases. If you've got any questions or comments, put those in the Q&A window, and I can answer any questions on any of those use cases as we go. So as I mentioned, one of the big areas of investment within NSX has been to broaden the platform support. Historically, NSX has been very focused on a virtual machine type workload running on a vSphere-based platform. However, we've broadened the hypervisor support beyond vSphere, such that we now support both vSphere and KVM. Within vSphere and KVM, we support both a virtual machine and a container workload type. So if you have virtual machines running on top of your hypervisor, we can integrate NSX with the platform to support that type of workload. Additionally, if you have a container running in a virtual machine on a hypervisor, we can also integrate with that type of workload as well. As I mentioned, one of the areas of investment has been to broaden the platform support. We now also support bare metal infrastructure. So if you have bare metal workloads, a bare metal Linux server as one example, we can deploy NSX into that bare metal workload to give you, within the data center, consistency across both your virtualized estate, your containerized estate, and your bare metal estate. And that's enabled using NSX Data Center. What we now have as well is the ability to extend that into cloud. In cloud for us can be one of two destinations. We support a native public cloud destination, such as a native AWS and a native Azure. So we can deploy NSX Cloud into that type of environment to give you consistency between data center and native AWS, native Azure. The other type of cloud destination that we support is a VMware-based cloud destination, such as a VMware Cloud on AWS, or an IBM Cloud, or a VMware Cloud destination that's hosted by any of our 4,000 VMware certified provider partners across the globe. So ultimately what we want to be able to give enterprise IT is the choice to deploy virtual machines, containers, bare metal workloads in the data center, and to also adopt cloud-based services from any of those cloud destinations that I've just described there. So at a high level, that's what we're driving across both data center and cloud locations, and these same principles apply to the edge location. So if you're running a hypervisor in an edge location, or containers, or bare metal, we can extend this model also to the edge location using NSX Data Center. I've referenced a little bit so far the cloud native integration, and I just want to talk a little bit more detail at what we're doing here. So with cloud native application frameworks such as Kubernetes as one great example, Kubernetes requires a networking technology to operate. Out of the box, Kubernetes comes with a number of options for networking and security. Some of these options are open source technologies, such as Flannel, that provide you a very specific capability. What we're doing with NSX is replacing those open source technologies with an enterprise-grade networking and security platform that gives you layer 2 through layer 7 networking and security technologies. So we provide you switching, routing, load balancing, firewalling for your cloud-native application architecture in place of those open source technologies that may just give you a subset of that capability. What this enables for an enterprise IT organization is a single platform in NSX that supports both traditional and cloud-native application architectures. The way that the integration has been developed, we are fully automating the NSX platform, so we're able to deliver networking and security services at the speed of the developer deployment. We can extend the concept of microsegmentation from a virtual machine to a container, so each individual Kubernetes pod becomes its own security boundary. And from an operational perspective, we give you the same levels of visibility for your Kubernetes deployments as we would for your traditional virtual machine deployments. So from a data operationalization perspective, again, we make it easy from a network perspective to gain visibility into what is going on within your Kubernetes deployments. So at a high level, that's what we're enabling for a cloud-native application framework. And then lastly, I spoke about this concept of multi-cloud networking with VMware NSX. And really, this is focusing on NSX's ability to span beyond different locations. We can span between different data center locations. So if you've got multiple data centers, we can deploy an NSX fabric across those different data center locations. If you've got data center locations and public cloud locations, as I mentioned, using NSX Cloud, we can extend NSX into those cloud locations. And really, this concept of extension beyond different locations enables the three use cases that we can see here. So on the left-hand side, the first use case that this enables is consistent security policy. So what this means is that you can secure your applications regardless of where those applications are residing. So if those applications are distributed across data center locations, we can secure those applications across those data center locations in a consistent way. If you've got hybrid applications between data center and cloud locations, again, we give you consistent security policy between data center and cloud location. Because we also extend our network services across these locations, this enables disaster avoidance and disaster recovery of both native cloud-native application architectures as well as traditional application architectures. So what disaster avoidance means is that rather than having a traditional active-passive across your different locations, you can have more of an active-active configuration. So my application can be deployed across different locations in an active-active configuration. If one of the locations fails, because the application is active across different locations, I wouldn't actually see any disruption to the service itself, and it would remain operational. Additionally, disaster recovery means that in a disaster scenario between an active and a passive site, as I have consistent networking and consistent security across those active-passive sites, in a disaster scenario when I'm recovering to my passive site, because I've got consistent networking and security, I don't need to worry about any reconfiguration of the workloads. The workloads will be recovered with the same IP configuration in the recovery site, which will speed my time to repair, time to recover of an application. And the last use case is around workload mobility. As we now have consistency between these different locations, consistent networking, consistent security, this means from a workload perspective, I can move that workload between these locations and still preserve the configuration of that workload, thus giving me portability and mobility of workloads between different locations. Those locations could be different data center locations, or they could be data center and cloud locations. So from a multi-cloud networking perspective, those are the three use cases that we enable. So drawing towards the end of this webinar, I just want to follow up on a couple of additional sources of information. So we've got some really good communities with NSX that can be accessed through communities.vmware.com. And there's additionally a very, very good network virtualization blog that can be accessed through blogs.vmware.com/network virtualization. If any of what I've discussed is of interest and you want to get a deeper level of understanding of how this integration works or how this capability works, I would advise taking a look at the hands-on labs, which are accessible via labs.hol.vmware.com. As I said, those are free to access, and it gives you a sandbox environment in which you can get some hands-on experience with the technology that I've just described. As I said, if you've got any questions or comments, please put those in the Q&A window, and I'll do my best to answer those now in the remaining time that we have. But otherwise, that was it from me. So thank you for dialing in, and I hope that's been useful.